Optimizing game performance for different platforms is essential to ensure smooth gameplay, optimal frame rates, and a positive user experience across a range of devices. Here are steps to optimize game performance for various platforms. Set performance targets. Define performance targets based on the capabilities of the target platforms, such as minimum frame rate, resolution, and graphical fidelity. Consider factors such as the hardware specifications, screen resolution, and processing power of each platform. Profile performance. Use profiling tools and performance monitoring software to identify performance bottlenecks, CPU and GPU usage, memory usage, and other performance metrics during gameplay. Profile your game on each target platform to identify platform-specific optimization opportunities. Optimize graphics settings. Adjust graphics settings, such as texture quality, resolution, anti-aliasing, shadows, and post-processing effects, to balance visual fidelity with performance on each platform. Provide options for players to customize graphics settings based on their hardware capabilities and preferences. Implement level of detail, LOD. Use level of detail, LOD, techniques to optimize rendering performance by dynamically adjusting the detail level of objects based on their distance from the camera. Implement LOD systems for meshes, textures, and shaders to reduce rendering overhead and improve frame rates. Optimize rendering pipeline. Optimize the rendering pipeline to minimize draw calls, batch rendering, and overdraw. Use techniques such as object culling, occlusion culling, and frustum culling to reduce the number of objects and polygons rendered each frame. Optimize asset loading and streaming. Optimize asset loading and streaming to minimize loading times and memory usage. Use asynchronous loading, streaming, and caching techniques to load assets dynamically and efficiently during gameplay. Implement asset bundling and compression to reduce file sizes and optimize storage space. Manage memory usage. Manage memory usage to minimize memory leaks, fragmentation, and excessive allocation. Use memory profiling tools to identify memory leaks and inefficient memory usage patterns. Implement memory management strategies such as object pooling, resource pooling, and memory reuse to optimize memory usage and performance. Optimize physics and AI. Optimize physics simulations and AI computations to minimize CPU usage and improve performance. Use physics optimizations such as collision culling, simplified physics meshes, and rigid body constraints to reduce the computational cost of physics simulations. Implement AI optimizations such as behavior tree pruning, spatial partitioning, and pathfinding optimizations to improve AI performance. Test and iterate. Test your game on each target platform to evaluate performance, stability, and compatibility. Gather feedback from playtesting, peer review, and user experience testing to identify performance issues and usability problems. Iterate on your optimizations based on user feedback and performance metrics to achieve optimal performance on each platform. Support multiple platforms. Build your game with cross-platform compatibility in mind to reach a wider audience and maximize market potential. Use platform-agnostic development tools and frameworks, such as Unity or Unreal Engine, to streamline development and deployment across multiple platforms. Test your game on each platform to ensure compatibility and performance consistency. By following these steps and adopting platform-specific optimization techniques, you can optimize game performance for different platforms and deliver a smooth and enjoyable gaming experience across a variety of devices and hardware configurations.